Hey everybody, how's it all going? So today we're going to fix a MacBook before the stock market bubble crashes. So first thing I'm going to do is I'm going to clean off my desk a little bit. Let's take a look at this MacBook and try and figure out what's wrong with it. Looks like the board's already been taken out of the case. Alright, no big deal. Doesn't look like there's any funny business here from the first look. I'm just going to unplug the SSD before we start, because the SSD has all their data. And there's no need to work on the board with the SSD in there. I see the SSD is screwed in. There's no need for that. Touch the desk, de-staticize myself, and get started. As you can see, we have 5 volts at 35 milliamps. Now that's not something I've seen before. I haven't seen 35 milliamps. That's a weird, strange one. But 5 volts is very telling. What 5 volts tells me is that the chip's responsible for communicating with the charger and requesting that it gets 20 volts instead of 5 volts is probably not turning on. And one of the main reasons that this doesn't turn on is that it's not getting its PP3V3 underscore G3 hot power rail. So we're going to try and measure and see if that's present, and I'll open up the schematic to show you why it is that that's something that I check. First thing we're going to do is try and get the multimeter on the screen. Now, we may not be able to get the multimeter on the screen. Do recall that this software is made by Paul Daniels, an agent provocateur of Rossman Repair Group for the longest time. He develops our in-house software that, yes, might as well have SolarWinds as our partner at this rate. Anyway, so what we're going to do here is we're going to open up a schematic for this board. I'm going to open up the 820-00840 schematic, and we're going to get started. So I can show you exactly why it is that I care about that main power line of PP3V3 underscore G3 hot. So if we go over here, now let's just go over to the charging port, and I will walk you through how this works. First thing I need to do is close signal because Erica is message spamming me at the moment, and I don't want that to show up on screen. Hopefully someone can make that stop. Okay. So the first thing we do here is we go to J3300. J3300 is going to be our charging port, I believe. Am I right here or am I wrong? Let's see. J3300. Is this it? Okay, that's strange. It doesn't look like a charge port on the schematic to me. That's weird. Well, it says USB-C connector over here. So I'll just take it that they drew the port in a way that they didn't usually draw it in older drawings. So this is the USB-C charge port. And on the USB-C charge port, we're going to have things like our 20-volt line. Let's see if I can find that on the screen over here. There's our 20 volts. Here we go. So PP20V USB-C XA. So the stuff like up here, that's going to be the 20 volts coming in from the charger. But there's also going to be communication going on. And that communication goes on some of these lines that you see here, like USB-C XA D2R, R2D, all that stuff. But you're also going to have this one line that's called CC1 or CC2 or something like that. So here you go. So you have USB-C, XA, CC1 con coming from the charge port. Now that is going to this resistor, and this resistor is then going to the CD3215 chip. Genuinely appreciate it. Thank you very much. But I gotta fix my board. I can't think about Dota, or else I will never get anything done. So this is... Yeah, I'm in low priority pool in Dota because when I was dumb enough to use Linux for gaming, it would crash. So I got called a leaver in some games. So I got to work my way up from low priority. Anyway, you also have USB XA CC2 con over here, which is another line that goes from the charge port over here along to a chip. There it then goes to the CD3215. So this CD3215 over here, this U3100, which is our USB-C controller chip, if I bring that up on the schematic, you'll see that right here. Here we go. USB-C port controller needs to speak to the charger, and that's the way it does it. Now this chip needs to get its voltage in over here, V in 3V3, PP3V3 underscore G3 hot in order to work. And if it doesn't have its PP3V3 underscore G3 hot, it's not going to work and the chip's not going to do its job. It's pretty much going to be like Oreo trying to catch mice. So we need to see if that power rail is present, and I'm going to guess that it's not. And if it's not present, then we got to figure out why. So let's get this on the screen. Okay, so let's just get some measurements going on here. So we're going to see if the area over here, PP3V3 underscore G3 hot, is present on the board. And let's do it. So the meter is in voltage mode. Put the black probe on ground. Put this probe over here. And we have 0 volts. So now we got to figure out why it is we're not getting PP3V3 underscore G3 hot. So we're going to go to the section where PP3V3 underscore G3 hot is made on this board, which is going to be the U6990 area. So this is going to be the power supply. What this does is it turns either the battery, PP bus G3 hot, or the charger, PP3V3 underscore G3 hot, the PPDCN G3 hot, into 3.3 volts. Now remember, this rail needs to be present before anything else works in the machine. It's going to be powering a lot of important systems. It's the first power rail that needs to be present, which means it needs to be there whether you're only using the battery or if the battery is dead. So if the battery's dead, it's going to be powered off the charger. If the charger's not plugged in, it's going to be powered off the battery. This is the first rail that has to get started. So it has 2 possible inputs, because you could either be using the machine on battery only, or you could be using the machine when the battery is completely dead. And that is why you have 2 separate inputs. So what we're going to do here is we've already measured 0 volts over here. I'm just going to check to see if there's a short at the output, and then I'm going to go all the way back to the beginning and go back there. So what I'm going to do is check out R6999, which is right over here. That's the output. And we're going to see if we have a short circuit there, and I sincerely doubt that we do. But you never know. It doesn't usually happen. So we check that, and you'll see no short circuit, 12 kiloohms to ground. Next up is we're going to see if we're getting input. So on this circuit, the diode over here, D6905, is where we're going to be getting input. Now, I'm going to be looking for PPDCN charger because I don't have the battery plugged in. So do we have this on R6906? Well, let's find out. So we zoom in on the board a little bit more here. I'm not using the microscope yet because I don't need to. Interestingly enough, all right, so we get 5 volts DC, but then it turns itself off. 5 volts, and then it turns itself off. Now that turning on and off and on and off is typically indicative of a short. However, if you take a look over here, you'll see that on this schematic, let's just get it over to the schematic only page. As you'll see here, my God, that is obnoxious Linux. Oh my, stop with the blinking, Jesus Christ. Can you join us here in the 21st century? Anyway, so this is not shorted. So we do not have a short circuit over here. However, this is blinking, which means it is possible that we have a short circuit over here. Thanks for deciding to do a stream. I'm happy about that. Thanks, Mario. I appreciate it. We'll see if it winds up being a worthwhile stream or a crappy one. Now, again, the whole power going up and down, up and down, up and down, that is indicative of perhaps a short. But again, we don't have a short circuit over here, so where could it be? Well, the only place left that I imagine where there's something going to ground is either the chip itself, U6990, C6991 going to ground, or C6990. So let's take a measure. So I'm going to go over to pin 3 of D6905 over here. We're going to click that button so that it shows up in Paul Daniels' majestically buggy software. And that shows me that that diode is going to be right up here. Right up here. Pin 3 is over there. Now, in order to make a proper measurement, we're going to unplug the charger. And we're going to check for resistance to ground over here. And we check for resistance to ground. Now here we go. 166 ohms. So that's not enough that you're going to see stuff explode. But you have to keep in mind, 160 ohms to ground on a 20-volt power line? Nuh-uh. That doesn't make any sense. Now, when you have a low-voltage power line, let's say you have like a 1-volt power line, and it's powering a CPU or a GPU that's going to be using 60 or 70 or 80 watts, you're expecting there to be a low resistance to ground. If you check out anything like an Ohm's law calculator, you'll be able to see that you're expecting a low resistance to ground because it's supposed to. If you're using a lot of power at a really low voltage, that is just the way things are going to go. So let's say we go to Ohm's law calculator here, because I get this a lot. People will ask me, why isn't this a short? Or I found the short, it's CPU V-core, and it's not. So let's say we have a CPU. Let's say the CPU runs off of 1 volt, 1 volt, 20 watts. And what we're going to do is we're going to look. Hello, it's my first day at Apple is this week. I'm going to bring back repairs. Marky, if you manage to do that, I will tip my hat to you. Maybe even give you some of my BlackBerry shares. But that would be awesome. That would really make my day. Once the culture catches up and you don't really even need right to repair as a law, because the people that wind up becoming engineers and business people and so on and so forth, they see the value in repair and they don't want to be a part of anything that would take it away from normal everyday people because they grew up around it. And that's kind of what I hope to bring back here, make all this stuff fun again. So let's see what the potential components are that could be causing our problem. So we have 150 ohms to ground, which I'm guessing is a bit much here for a 20 volt input. So what do we have? So we have C6991 over here. It could be that. It could be C6990, which is actually on the other side of the board right here, or it could be U6990, which is the chip over here. So actually this board is a trickster. So I haven't mentioned this before, but this board is actually an absolute troll because there's another cap on that line, but it doesn't show up on this page because it's next to the ISL 9239, and this will often troll the hell out of people. It's right next to the ISL 9239. It's another cap on that rail. It's a C7078. And the best part about C7078 is that on the 15-inch schematic, the cap is actually off the screen and the line is not going to the chip. On the 13-inch, the schematic is done a little bit better than that. So let's see if any of those look overly damaged. Let's see if we can get an obvious hint before we go and just rip things off willy-nilly. So this is cap 1, and this one actually looks fine. This is cap 2, and this one also looks fine. So we're going to go over to cap 3 and see what cap 3 looks like. And cap 3 up here also looks fine. It's got a weird little line in the middle, but otherwise is, yeah, that's a troll. Okay, that's interesting. That is most certainly interesting. That's, All right, so we're going to rework our theory here. All right. So perhaps it's not a short. Perhaps 150 ohms is okay. Again, we're just guessing here. I haven't even taken a board to compare with yet. The next thing I'm kind of curious about is this being told to turn on? So if you take a look, the ISL 9239 over here is supposed to be sending out PM, EN, P3V3, G3 hot, and that's supposed to be sent out to the U6990 chip as its enable, which you can see here on pin 10. I remember watching you in high school, being a sheep and wanting to design unrepairable devices and snarking at you and right to repair, and then I got my engineering degree and want to make things repairable, just because you. I don't know if that's a troll or if that's serious. If it's serious, you brought a tear to my heart. If it's a troll, well, I don't know. I'm kind of immune to them at this point. But I'll assume the best and hope that it's a good thing. I'll hope that maybe I actually changed something. Thank you. And so over here, we have PM, EN, P3V3, G3 hot. And that is going to enable this. That's going to turn this chip on the same way that I get turned on when I wake up and BlackBerry's up 25%. So this chip, U6990, it needs to be told to create the 3.3 volts. And it's going to be told to when it gets this on the enable. So that's on pin 10. So let's see if our enable is actually present, because we may not have an enable present, and that may be what's causing our problem, rather than it being an issue of there being a short. So one way to really find that out would be to measure on the board where our 6991 is, where our enable is. Marky says I'm legit. Well, if that's the case, then thank you very much. You actually just kind of made my day. I really appreciate that. Thank you. Okay. You made my day after a pretty shitty year and a series of shitty months, so thank you. Okay, let's put this back on the screen and see if we can get it to show up. Again, Linux. That's a good Linux. All right. So we check over here. And we're getting 2 volts. I think we're supposed to get like a 3 or a 5 or something like that. So that's kind of strange. Yeah, 2 volts seems low. So now I'm wondering to myself, is the problem a short circuit on the DCN, or is the problem the ISL9239 not putting out an enable that's high enough? Because I think that's supposed to be closer to 3.5 to 5. Yeah, the DCN is being pulled down to 1 volt. That's a big problem, as you can see. So DCN is 1 volt over there. But DCN is 5 volts over here. Okay, so check this out. So the input to the chip is being interesting. So either the diode is bad or there's a short circuit. So which do you think it is? Is 150 ohms to ground so low that it's pulling it down? Or is it the diode that's bad? Now, here's what I think. If we go to our Ohm's law calculator up here, and we just do a couple of little basic calculations, you'll see that in the Ohm's law calculator, if we have the voltage at 5, and we have the resistance at the 160 ohms that we measured before, that comes out to 0.15 watts being used. Now, I don't think 0.15 watts being used is enough to actually to destroy the system. I don't think 0.15 watts is going to drag the charger from 5 to 1. I think what's going on is it may be that this diode has died. Now, I'm tempted to believe that the diode died because there was a short to ground, but the thing is, there's the short is 160 ohms, which is just not convincing to me as something stressful enough to kill the diode. I watched your salesmanship series and it was impactful. Thanks. Oh, I'm glad. You should read that the book that I was probably riffing from at that point. It was Start With No by Jim Camp. Yeah, that guy's a genius. I'm just a dumbass who, in that series of videos, wasn't even smart enough to focus his freaking camera. Now, again, the diode died, but what I'm really curious about here is, did it die because it died, or did it die because 150 ohms is too low on the DCN? And this is where having a known good would be somewhat helpful. Again, I'm not of the mind that I should be calling 100 something that's going to take 0.2 ohms or whatever a short. But because it's easy, I'm actually going to remove everything on that line anyway, and I'm just to see what the resistance is when I'm done. So I'm going to remove the 3 caps on that section. Just like that. Those 3 caps are now gone. I sincerely doubt that this U6990 is what was pulling anything down. But for the heck of it, let's take a quick measurement now that that's done and see if anything has changed. Let's see, we go back to ohms mode. Okay, so now that I've removed the caps, we have 6.5 million ohms to ground rather than 150 ohms. So here's what I think happened. I think that actually was enough to destroy the diode, which is weird because, again, if you take a look at the Ohm's law calculator, a short of 150 ohms, 160 ohms, is going to mean that it's taking 0.15 watts, which that diode should be more than capable of being able to pass through. Also, if I raise it to 20 volts, then that diode would have 2.5 watts put through it, which, okay, maybe once it hits 20 watts, then the short would have 20 volts. Once the charger hits 20 volts, then that short might have been enough to eventually kill the diode. So that answers that. So I'm going to get myself a donor, and we are going to replace those parts. After I replace those parts, I am going to see if it works. If it works, great. And if it doesn't work, then I will put my elbow through the board, destroy it, and go off to lunch. How about that? All right. You know what? 2 strikes, you're out. First, you're saying that my mic is off, and now you're saying that shit, just random other shit that's not true. You're out of here. All right. Does Apple get diodes from unit pack power? No, the diode is doing what it's supposed to. They're probably getting the caps from unit pack power, if I had to guess. All right. Some nice fresh solder on there. By the way, everybody, say hello to Aaron. He's a moderator that often has useful content. He's also one of the best unofficial private investigators / detectives I've ever seen on the internet. All right, next up here. BlackBerry did have a good day today, and one of the things that what I'm noticing now is that my decision to start streaming was actually one of the best things that I could have done for it. So check this out. So I started streaming around here, and now we're here. So the day was on this path, so check it out. So today we were on a path from here to boom. And then Lewis starts a board repair stream, and now it's doing this. So for any of you who are holding BlackBerry stock, you're welcome. All right, now we return to the board repair. So last thing we need to do is add some solder over here, because we're going to replace this cap. Now, you may ask, why did I replace all 3 caps rather than try and figure out which capacitor was shorted? Well, there is a cost to diagnosing. There's a time cost involved. And that time cost involved in figuring out which specific cap it was is a considerably higher cost than just replacing all of them, honestly. These caps cost virtually nothing, and it's the time that matters. I got a little bit of excess solder on this fuse over here, but it's fine. No, it's not. It's fine. All right, so now I'm going to replace each one of those capacitors. And then we are going to replace the diode. If BlackBerry hits 30 this year, I will buy a BlackBerry and use it as my primary phone. I will buy a BlackBerry. I apologize to the MacBook repair god for the very mild malforming on the plastic on that connector from the hot air. I could have avoided that. It's fine. It's not enough that it's going to damage anything or like keep it from working or making contact or anything like that. I know when it's enough for that, but the guilt still gets me. Alright, let's just move this back where it's supposed to go. We're going to replace the cap, another cap, and the diode. BlackBerry is on its other leg up. Good job, BlackBerry. BlackBerry doesn't even make phones anymore. They just outsource. No, you don't understand. If the stock goes to $30, I will purchase a BlackBerry and I will use it as my daily driver. All right, next cap. I'm going to get this right over here. If your hand is shaky, when you get to the right position, push down, because pushing down will result in there being resistance against your hand, which will keep your hand from being able to shake. The more you know, the more you can compensate for your brain and your nervous system defects that keep you from being able to be a good board technician. So this cap is going to go here. We measure and see if the short is gone, and then we're done. Now, once it's done, what you can do here is you add a little bit of flux to the board. All you got to do is get it in the vicinity. And then once you've soldered in the vicinity, then the hot air will make you look like a genius. See? That's called surface tension. The magic of surface tension means that it's going to find its way in a place just like that, and it'll look like stock once it's done going through the ultrasonic cleaner, and the customer never has to know that a complete and utter spaz worked on their board. It's magic. All right. Now, we're going to rapid cool this board a little bit. Do this. A little bit of rapid cool. Rapid cool. Da, 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 da. Okay, now we plug it in and see what we get. As you can see, it's taking 600 milliamps, and it's going to settle around 550 to 560, meaning that we've completed our boot cycle, and it is now turning on. So that's about it for today. What we did to fix this board is we identified that there was a minor short circuit on the input section of the PP3P3_G3 hot creation circuit. We also noticed that happened to damage the diode. So we removed the diode and removed the items that would have caused that potential short. I didn't remove just one item after finding the specific item that was causing the short for several reasons. The first is that it is actually quicker for me to replace all three caps than for me to figure out which one it is. The second is that with a short circuit of 160 ohms, that it's not going to present itself very obviously, meaning it's probably going to require a thermal camera and waste a good portion of my time. If I have to actually get out of the chair to pick up the thermal camera and bring it to the desk, that's a gigantic waste of time, carbohydrates, and calories that I just, at my advanced age at this point, I don't feel like wasting. So we removed those three caps. We measured. We went from 160 ohms to about 5 million ohms, which meant that was indeed a short. And then I replaced the diode behind it that, if it wasn't dead from dragging 2.5 watts through it, probably would have been dead soon thereafter, causing the customer to return for warranty and be mad that it wasn't fixed right the first time. Now that that's done, it boots up. This board is going to get cleaned up, ultrasonic, taken off to the testing people. They're going to test it, reassemble it, well, not in that order, and then bill the customer. That's it for today. And as always, I hope you learned something. I'll see you all in the next video. Bye now.